Today we're inside Bruco because it's 20 degrees outside, which is uncharacteristic for us Texans. But we're doing a test inflation on a dome that we're working on for a project in Florida. It will immediately be warm again. Detailed science of manometers. This dome will have two prolate ellipsoids, so that's kind of like a cone head shape. And these two prolates will be next to each other with a huge saddle in between them. The problem with big saddles on prolates is when you cut that big of a hole in a prolate, it doesn't want to stay prolated. So the reason for this test is we're putting some baffles in it to try to see if we can't retain that shape, so that after we inflate it, we can foam it and put the framing in, and then we should be able to knife those baffles off and have it keep the shape that we want it to be. So like I said, it's 20 degrees outside, and these guys have opened the door here, letting all this cold air in. But one of the really cool things about monolithic domes is all of this concrete mass in here, even though he's letting in all that nice cold air, it will immediately be warm again. After the door is shut, that cold air will just be absorbed by the concrete. This facility in here that we're working in is incredibly, just super warm right now. I mean, I think we're at 75 degrees in here. And we're cooling this whole facility with two mini splits. You can see one there in the middle and another one down here at the end. And that's it. Super energy efficient. Back to the project at hand. We're going to inflate this dome with these two prolates here in just a minute. All right, so we've got these funky blue colors because this is just fabric we had left over from projects. This dome looks, the big prolate looks like it's holding its shape correctly. We're going to go inside with the laser in a minute and measure it. And the little one does too. The baffles seem to be doing their job. The middle does seem to be rounding out a little bit. I mean, I can't remember what the profile should be, but it does look like it's coming out a little bit there, which I guess is to be expected. So the profile of that tunnel may be just a little bit shorter than it's supposed to be. Probably not a deal breaker for the project, but it'll be interesting to watch that as we increase the pressure. Right now I have so little pressure, it's just barely holding it up into the shape. But I want to get some preliminary height measurements and stuff at just this minimum pressure. And that way we can see that if increased pressure makes them get smaller or bigger. I suspect there will be a lot of tension on those inner walls, so we may want to go put some tension marks there and see if we can watch that, see how it gets tensioned up. No, go for it. The crew here is going to get my manometer going so we can measure some pressures. We've got our inflator fan here at low pressure right now. The detailed science of manometers. Stupid simple devices, but very important. Okay, so our test dome has been inflated to 2 inches of pressure. We just got done doing a whole bunch of laser measurements, so next we'll go in the office and create a point cloud so we can see how it inflated versus what we designed it to inflate to. clear to us by looking at it and measuring the heights of the dome that the dome shapes are what they're supposed to be. The saddle, I think, is still coming out a little bit too far here in the middle, so it's probably too low. Probably accounts for some of that wrinkling that's going there. But let's go ahead and take a walk inside. Hopefully it won't be too loud. This inflator fan is pretty loud, and then it'll probably be dark for a little while. We'll do our best. I've got a light inside here, so as soon as I get in, I'll be able to turn that on. There we go. All right, so our prolated shape, you can see that, looks pretty good. The wall is doing its job. You can see that there's not a ton of tension there, but definitely some. When we get done with our point cloud, we're going to cut those walls off and see what it does to the inside of the dome here. Crawl underneath that wall. Bring our light with us to the next one. Just slide this underneath there. There we go. And we're into the smaller dome here, which is just barely big enough to stand in, really. Okay, so that's it for the inside tour until we come back and cut those baffles out. See the manometer tube here. We'll go outside and check that out. All right, let's roll. Trying to keep those holes small so we can retain the shape best we can. All right. All right. So we get outside here, and you can see our airlock, our inflator fan. The inflator fan we keep in the Caterpillar is a little different. It's a three-phase machine that we put a speed control on, so we can use it for moving airforms around and inflating them here. It's a manometer that we make. We've got these rulers that are 3D printed so that they show the right amount of pressure on them. So 2 inches is in fact 2 inches of pressure. We're just a little under 2 inches right now. Okay, we're now sitting here at the computer where we're able to kind of analyze that shape a little bit. So what you see here is the 3D model of what the design goal was, and then these purple points here are the points that our laser was able to give us. So it gives you a little bit of a point cloud that you can kind of analyze and measure different things. We're not going to go into a ton of detail, but you can see here, this is the lower profile pressure. And so the center was kind of pulled towards the saddle a little bit, which, you know, now that we're sitting here and we've done the test, it's behaving exactly as we kind of expected it to. You know, these haven't quite hit their mark yet, but with some more pressure, they probably will. The baffle is doing its job. Now that was one of the things we wanted to learn, was just how well the baffle is going to help retain that shape. The saddle is doing exactly what we had talked about in the video, where the top has come down and the sides are going out, right? That's exactly what we'd expect. anything that is inflated wants to be round. So that's what's happened. That saddle has gone round. So we were able to keep the prolates right where they were supposed to be. And you can see on this side, it's really rounded out a lot more than it was supposed to. And so, yeah, I mean, it's doing exactly what we thought. So that was the pressure, 2 inches of pressure. And then we went back and put it up to 4 inches of pressure. And I think that was really fun because the dome, the top center of this dome came back a lot better where it was supposed to be. And the dome is, just about the right profile. And you can see that it kind of grew all around here, but it grew in the shape that it was supposed to. And then, yeah, the saddle really, really grew. So then we didn't exactly pattern it for that kind of pressure, so I'm not surprised to see that it has expanded out. But yeah, you can still see how much more round that center portion is. Yep, and then we cut the baffles out, and it just went super round, right? You can see that these, instead of being up high like they were, they have rounded out. And the domes actually stayed more prolated than I would have expected. But they definitely came down. So the top came down a ways and went kind of round. But then, yeah, here at the saddle connection, it really came down. So, yeah, it's exactly what they expected. So the baffles did their job. They kept that dome with the right shape. The challenge of building the dome, of course, is building it with the stupid baffles in there are going to be kind of a pain. But it's something we can work around to preserve the shape. And I mean, I think this is just our part of our goal is to understand our abilities to do more freeform shapes. And this is where we're going. So back outside, we'll go and we'll just let this video run a little longer, just kind of show you as we cut the baffles out what it looks like. And I don't know if anybody wants to watch the rest of it, they're welcome to. If not, thanks for watching, and we'll just keep learning. All right, we're back inside the test dome. We've got the first profiles done. We did 1 and 2 inches, which is probably relative to half build pressure, and then we did 1 to 4 inches of pressure, which replicates the pressure the building will actually be under. And so now we're going to cut this baffle out. If I cut this down, I don't know if you can see that on the camera there, but I mean, there's 1.5 inches deflection there already. And you can see it moving. All right, I'm gonna go outside and get a, I might just turn the air off for a little while and see if we can't get it to come down on its own. All right. Can you see me, camera? All right, so then we'll just let the air bring it down and then we'll cut it out. Maybe we'll enjoy a little more silence while we're doing it. This thing is deflated a little more. Let's finish the job here. Oh no. Right. Let's cut this down a little bit. Let's go ahead and turn the fans back on. We've got this back to pressure. You can feel some tension there. Let's cut this open. Try to get it close without stabbing a hole in the dome. Get a feel for how much tension's there. You can already see the gap widening, right? So let's make it a little wider. You can see the dome pulling away. And now we're 2 inches, if not a little more already, of deflection there without the baffle. Well, the baffle is definitely doing its job as we predicted that it would. And as it comes away, you can really get a sense of how much restriction that thing was doing. All right, now that we've got these baffles cut out, it really makes kind of a difference of what it looks like inside, obviously. So it's pretty cool. It'll be really interesting to see what the laser says. And then we'll go outside and we'll take some pictures. It may be hard to see on the camera, but I can tell this has already gone from a prolated shape down to a circular shape. So that's definitely going to affect the profile. And that's it. That's our test. We're going to go compile our findings and submit them to our customer, and they can decide whether they want to go with this prolated design with the challenges that it comes up with, or maybe transition to a spherical design. You can see on these computer renderings what that difference would look like. The spherical one is completely inflatable, of course, completely inflatable with some supports around the side saddles, where this prolate one would require baffles in order to be inflated.